Hello everyone! Today I would like to review OSPF Path Selection. I want to speak about intra-area routes, inter-area routes, external type 1 and external type 2 routes, link cost and equal cost multipathing. So let's talk about it. To create a loop-free topology of shortest path, OSPF runs Dijkstra's shortest path first algorithm. Each and every router uses the same logic to calculate the shortest path for each network. There is a priority, there is a logic how to choose or prioritize routes for path selection. And the first one in this logic is intra-area routes. Then inter-area routes, next one goes external type 1 route, and the last one external type 2 routes. Let's talk about link cost. The shortest path metric is based on the cumulative interface cost from the router to the destination network. That is why the link cost is the essential element of Dijkstra's shortest path first calculation. OSPF link cost assigned to the interface is calculated using formula cost equal reference bandwidth divided by interface bandwidth. Reference bandwidth is 100 megabit per second, and as you can see from this table, there is no difference between fast Ethernet cost, gigabit Ethernet cost, and 10 gigabit Ethernet cost. That is why reference bandwidth can be changed under the OSPF process with the command autocost reference bandwidth, and then you can put bandwidth in megabit per second. Considering the new value for reference bandwidth, remember that interface cannot exceed 65,535 because LSA field is 16 bits, and reference bandwidth should be changed on all OSPF routers. Interface OSPF cost can be set manually with the command IP OSPF cost from 1 to 65,535 under the interface configuration mode. Path metric can exceed 65,535 because all the links metrics are calculated locally. Intra-area routes. Routes which are advertised using an OSPF LSA type 1 for an area are more preferred than routes advertised using OSPF LSA type 3. If there are multiple intra-area routes for the destination, then the path with the lowest total path metric will be installed into the OSPF routing information base and then presented to the router's global RIB. For example, in our example, we have area 1 and we have area 0. This router R1 will install a route to the network 10.1.1.0 through router R4, but not through area 0, because this route is inside one area and it is more preferred than to use area 0 or to use OSPF type 3 routes based on the OSPF LSA type 3. So even though this route is much slower than this one, we will see it in the example. If there is a tie-in metric, then both routes are installed into the OSPF routing information base. So let's see example. So let's see this example. We have same network, we have area 0 here, and here we have area 1 and area 1. The cost of this interface 10, the cost of this interface link 10, the cost of this link is 10, and this one is 1. So let's see. Show IP, show run interface G00. You can see this is 1. Show run interface G01. Show run interface G01. This one is 10. So total path cost from this router to the network on router R3 to this network 10.1.1.1, which is loop back, through R4 is going to be 20, through R2 is gonna be 11, but our router will choose route through R4. Show IP route OSPF. Now we can see that route to 10.1.1.1 cost 21 via router IP address 10.14.04, which is our router R4. So as I said in the slide, intra-area routes are more preferred. Inter-area routes. The next in logic to choose the path to the destination is selection of the path with the lowest total path metric. If there is a tie in the metric, then both routes are installed into OSPF routing information base, and it is obvious that all inter-area paths for a route must go through area 0 to be considered as a candidate. Let's see our example. We have area 1, 2, 3, 4, we have area 0, and we have area 4, 5, 6. From route R3, which path to choose to reach network 10.1.1.0? It is obvious that this is going to be path with the lowest total cost. And as we can see, this is passed through R1, R4, and to reach R6. This is going to be 10, 1, 10, and plus 1, 22. Let's check it on example. This is the same network that we have on the slide. We have area 1, 2, 3, area 0, and area 4, 5, 6. Let's see what we have on router R6. Show IP interface brief. This is our destination network 10.1.1.6, and let's see which routes we have. Show IP route OSPF, and as you can see, we have inter-area route through router R1 here, and the cost of this path is 22, as I mentioned on the slide. Show IP OSPF route, and you can see that this is inter-area route cost and area 1, 2, 3, which in next hop IP and interface, outgoing interface. External route selection. External routes can be classified as type 1 and type 2. Differences between these two types of routes are as follows. First, type 1 route is preferred over type 2 route. Second, the type 1 metric is the redistribution metric plus the total path metric to reach ASBR. The farther from the ASBR LSA propagates, the more type 1 metric increases. The type 2 equals only the redistribution metric. It is the same for the router next to ASBR and for the router 10 hops away from the originating ASBR. Type 2 is the default external metric type that OSPF uses. So we will look in this in more details in the next few slides with examples. External routes type 1. As it was mentioned previously, type 1 route calculation uses the redistribution metric plus the lowest path metric to reach the ASBR. The farther away router from the originating ASBR is, the higher the metric for the type 1 route. For example, here we have EIGRP external routes which are injected into OSPF or distributed into OSPF here and here. And from the point of view of router R1, type 1 route is gonna be 10 plus 15 plus 10, and then plus redistribution metric, which is 20. So 20 plus 10, 30, 45, 55 to reach external route. If there is a tie in the metric, both routes are installed into the routing information base. If an ASBR is in a different area from the router, then the path of traffic must go through area 0. So it should always go through area 0 if in different areas. If there are two routes OE1 and ON1 available at the same time, the router will install ON1 into routing information base, as it always gives preference for a typical NSSA. Let's see an example, this network. So let's see example for type 1 external routes, same network that we have on this, we had on the slide, area 1, 2, 3, this area 0, area 0, area 46 also not so stubby area 57 also not so stubby area, R7, R6 are ASBR routers, and they have also a redistribution of the routes from EIGRP into OSPF. And here we have our external router with EIGRP routing protocol configured. Let's see what we have on this router. Show IP route. This is our external network, and this is links 79 and 69 networks. Show IP interface brief. This is loopback interface, which we consider as external network. Show RAM router OSPF 100. Oh, sorry, not OSPF, EIGRP. EIGRP. These networks which we add into our EIGRP routing protocol. And let's go to R6. Show IP interface brief. These are our interfaces all up. Show run section router OSPF 100. Here we can see this area, not so stubby area, redistribution of EIGRP routes with metric 20 and metric type 1. And show EIGRP. Nothing special. Let's see what we have. Show IP route. We have these routes. This is directly connected, and this one is this route is from the link between router R7 and external router. This is our external route, and these are EIGRP routes, because on this router we have two routing protocols configured. So let's go to R4. Show IP route. As we can see, these routes are our type 1 external routes with metric 30. 20 was redistribution metric, and 10 is cost on the link between R1 and R6. Show IP OSPF route. Show IP OSPF route. We can see our NSSA route list. Type 1 cost 30, forwarding cost 10. So total cost is 20 plus 10 is 30, and forwarding cost from this router to ASBR is 10. Let's go to router R1. Show IP route. Here we can see again our external routes, but now they are not L1 but E1. And show IP OSPF route. We can see external cost 55 now, and forwarding cost 35. Forwarding cost 35, this is 10, 15, and 10, 35, and 20 redistribution cost, total 55, and forwarding cost is 35. So the far we go from ABR, the higher metric cost for this external route type 1. Show IP route 172.16.09. Again, metric 55, type external 1, next hop router, and the route in this script, this is from 444. Okay, let's see, show IP OSPF database. Show IP OSPF database. This is our type 5 external link states, and this is our external networks. This is everything for this example. The main point is that route type 1 external route has metric which is redistribution metric cost plus metric from this router to ASBR router. Type 2 external routes. It doesn't matter how far router from the ASBR. External OSPF type 2 routes do not increment the metric. The metric for OSPF type 2 routes equals to the redistribution metric. For example, in our network, we have the same story. We have EIGRP router here with external networks, and we have a redistribution of EIGRP routes into OSPF on R6 and into OSPF on R7. From the point of view of R1, the metric for external route is gonna be 20. This is redistribution metric. If there is a tie in the redistribution metric, route with lower forwarding cost to the originating ASBR is preferred. If there is a tie in forwarding cost, then the both routes are installed into the routing table. ABR always gives preference to ON1 for a typical NSSA over OE2. And if there are two routes ON2 and OE2 at the same time, router will always choose ON2. Let's review this example in practice. And let's review this example for type 2 external routes. We have same network as in previous example, area 123, area 00, area 46, area 57. Also these two are not so stubby areas, R6 ASBR with route redistribution, R7 ASBR with route redistribution. And this is external router with EIGRP and external network. Let's go to R6 and show route. OSPF 100. Type 2 is default metric type for OSPF. So, show route section router OSPF 100. Show run section router OSPF 100. Here we have area 46, not so stubby area, redistribution of the routes for type 2, which is default, and EIGRP. This one is not default configuration, but even if you configure it for type 2, it just gives you this one, because this is default metric type for OSPF. And here we have network and router for EIGRP. Show IP route. We can see route to our external network. And let's go to R4. Here we should find our N2 network. Show IP route. And here we go. We have our 3 external networks and 2 type, which is 69, 79 and 16, and the metric is 20. This is 20 is redistribution metric. Let's see what we have. Show IP OSPF route. We can see our not unnecessary route list. This is our cost 20, forwarding cost 10. This is because we have also cost between R4 and R6, and that's it. Let's go to router R1. Show IP route. Here we have our external networks, and again metric 20. So as I mentioned in the slides, type 2 metric has a redistribution metric, and no matter how far this router from ASBR. And show IP OSPF route. And here we have external route list. We can see that external 2, cost and forwarding cost 35. This route is chosen because forwarding cost is 35, 10, 15, and 10. Let's see it. Show IP route 172.16.0.9. Here we can see that metric 20, type external 2, and forwarding metric 35. For different paths, the forwarding metric is going to be different, but here we have this route is chosen. And as you can see, and as it was mentioned in the slides, metric is 20. If the OSPF algorithm identifies multiple paths with equal costs, it will install those routes into the routing table using equal cost multipathing. By default, the maximum number of ECMP paths is equal to 4, but it can be changed using the following command under the OSPF process: maximum paths, and there you can put the number maximum paths. For example, let's say 8. Let's see this example. Well, let's review example for equal cost multipathing. We have the same network and we have type 1 external routes configured on these interfaces, but I changed the cost on all links to 10. So all this like route from R1 through R2 equals to route from R1 through R3. So let's see. Show IP route. This is a show run router OSPF. So this is metric type 1. Show IP route. Oh, sorry. Show run router OSPF 100. Also metric 20, metric type 1. So on this router, both routes to our external router on to external route on router X9 should be equal. And let's see, for example, on this router, show IP route should be equal, and total pass cost is 30, 10 plus 20, 30. And on this one, also 30. Let's go to router R1, show IP route. And as you can see, we have two routes for this external network, One goes through router R3 and the second one goes through router R2. They have equal total pass cost. And let's see, show IP protocols. As we can see, we have maximum pass configured for conf t router OSPF 100 maximum pass, let's say 8. This is how we change this number. Show IP protocol. And as you can see, this number is changed. This is everything I wanted to show you for equal cost multipathing. Thank you very much for watching my video. I hope you enjoyed it. Please don't forget to subscribe to my channel with the notification bell on and show your support by hitting like button. I hope to see you soon in my next videos, but for now just goodbye and see you soon.